Hello everyone. Let's solve an interesting question from Maharashtra State 2023 exam. Question is, which of the following statement is true? We have given four different statements and we have to determine which of these given statement is true. So let's verify one by one each of these given statements. So let's start with the statement in A. Every connected subset of Rn is convex. Is this a true statement? No. Clearly this is a false statement. To say it, for n equals to 2, that is for R2, that is for xy plane, S, which is equals to R2 minus set containing origin, is subset of R2. Okay, let's say it geometrically. We have just removed origin from xy plane. We have just removed this point origin from xy plane. Okay, clearly this set is path connected. Why? For example, take any two points in this set. Clearly these 2 points can be joined by path. Okay. Clearly these 2 points can be joined by path between. And that path is completely lies in this set. And hence this set is path connected. And we know that every path connected set is connected. So S is connected subset of R2. Now, is this set is convex? We know that a subset of Rn is convex if and only if for any 2 points in that set, a line segment joining those 2 points must also belongs to that set. Now, take any 2 points, say here, the point 1 comma 1. Okay, clearly this point belongs to S, and the point minus 1 comma minus 1. This point is also belongs to this set. Now, the line segment joining these 2 points is passes through origin. And we know that origin does not belongs to S. So the line segment joining these 2 points is not contained in S. And so by definition of convex set, S cannot be a convex set. Okay. So there exists a connected subset of R2 which is not convex. Okay. So the statement in A is not always a true statement. So this is not always a true statement and hence we mark it as incorrect. Okay. Now let's move to the statement in B. Every convex set in Rn is compact. Every convex set in Rn is compact. Let take n equals to 1, the most simple case, that is simple real line R. Okay, and take set as s equals to interval 1 to infinity. Okay, clearly this subset of R, and we know that a subset of R is convex if and only if it is connected. Okay, and we also know that only connected subsets of R are interval. So clearly as it is an interval, so it is a connected subset of R and hence it is a convex subset of R. Okay, so this is a convex subset of R. Okay, but is it compact? We know that by Hein-Borel theorem, a subset of R is a compact if and only if it is closed and bounded. Clearly this set is closed but it is not bounded, and so by Hein-Borel theorem this is not compact. So there exists a convex subset of R which is not compact. So the statement in B is also not true, that is it is not always a true statement. So we mark it as incorrect. Now let's move to the statement in C. The statement in C is every convex subset of Rn is connected. Is this a true statement? Yes, this is a true statement. I am not going to prove the statement in C here. I will just give outline of the proof. Okay. Note that S subset of Rn is convex if and only if for any two points of S, the line segment joining those two points is also contained in S. Okay. S subset of Rn is convex if and only for any two points of S, the line segment joining those two points is also contained in S. So from here we see that for any two points of S, there exists a path joining those two points and which is also contained in S. So from here we see that if S subset of Rn is convex, then there exists a path joining any two points of S and that path is also contained in S. So if S subset of Rn is convex, then S is path connected. And we know that every path connected set is also connected. So from here, this implies S is connected. Okay. So the statement in C is true. This is not a standard proof. Okay. Now let's move to the statement in D. The union of these two sets is convex. Is this a true statement? No. This is also a false statement. To see it, let's see it geometrically. The first set in this union, that is set of ordered pair xy belongs to R2 such that x greater or equals to 0 and y greater or equals to 0 is the set this. That is first quadrant. Okay. And the set in the second set in this union, that is set of xy belongs to R2 such that x less or equals to 0 and y less or equals to 0 is the third quadrant, that is this set. Okay. Clearly, this set, that is this shaded portion, the set indicated by this shaded portion is not convex. Why? Take any two points in this set. For example, take one point here and take another point here. Now, the line segment joining these 2 points, okay, is not contained in the set. Clearly, this line segment contains points which lie outside this set. So, the line segment joining these 2 points is not contained in this union and hence this union is not convex. So, the statement in D is incorrect, that is false statement. So, we mark it as incorrect. So, only 2 statements in these 4 statements is the statement C. Okay. So, if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.